Hello there, and welcome back. This is lesson 4 in our unit, The Atom, and today's lesson is called Electron Configuration Excited versus Ground State. So in the last video, we talked about average atomic mass and where the mass on the periodic table came from. And today we're going to talk about electron configurations, the energy levels or energy shells, Bohr diagrams, and excited electron ground state electrons, and also how glow sticks glow. Let's get started. So just a quick review from the different atomic history models. The Bohr model, again, this dude was Niels Bohr, and he said one of his most important contributions was that these electrons move in these definite orbits around the nucleus. And he also added that the electrons can jump from one level to the other. So if you think about, let me change the color here. Here's your nucleus. So nucleus. You have 1 energy level, 2 energy level, 3 energy level. You could have an electron here actually jump up and go back there and then come back down. So that's what he was saying. And what he said is that these electrons, depending on where their energy level, where they're located, you have different amounts of energy. So the closest you are to the nucleus, a smaller amount of energy, and the farther away you are from the nucleus, the more energy you had. So which energy level, 1, 2, or 3, has more energy? So level 3 has, in this picture, the most energy, because it is the farthest away. And level 1 has the least amount of energy, and it is the closest. And again, these electrons can jump a level and fall back down if they get excited. And we're going to talk about what that means. Again, we also talked about Erwin Schrödinger and his wave mechanical model and how electrons weren't in these exact perfect orbits, but rather in these clouds. And depending on their energy, they're locked into certain areas of that cloud. So, again, the orbitals, which he said are the most probable locations of that electron. And again, the farther away or the outermost energy levels, the higher energy the electrons are, and the electrons with the lowest energy are closest. So, if you look at this, I don't know if you can see it, but there's actually a red dot kind of flinging around. So every dot in this picture represents a location of where the electron was. So right there, that is your nucleus. And each dot represents a location of the electron. But you can kind of see a pattern where most of the time the electron is somewhere within that area. So that's the most probable location of the electron, and that is what an orbital actually is. So orbitals come in different shapes, and this is as far as I'm going to get into this with you. If you ever move on to take AP Chem, you learn a lot of this in a lot more detail. But they do look like kind of balloon animal shaped things. Okay, so just kind of to review, Bohr model says electrons go around the nucleus in these perfect circular orbits, where the electron cloud model, or the wave mechanical model, says electrons don't follow a definite path. They're more likely in a most probable location, which is called an orbital. And the most dense part of the cloud is where the most likely you are to find the electron. Okay, so this is the Bohr diagram. It's cool. Let's talk about how to draw these. So Bohr diagrams are used to show how electrons fill their shells. And so the first shell or energy level can hold 2 electrons, the second can hold 8, the third can hold 18, the fourth can hold 32. Once you start getting to like the third level and past that, it gets super, super complicated. So we're only going to really focus on the first 20 or so elements. And you see these spots in these energy shells are filled just like seats on a train. And so this is what I mean. If you're getting on the subway to go home, and you can sit next to annoying soccer mom, angry businessman, screaming child, or by yourself, where would you sit? Even if COVID wasn't a thing, you'd probably sit right by yourself. So you go over there and sit by yourself, just like these electrons. And I promise I'll explain where I'm going with this. Now, if you get on, a stop later than you normally do, and your seat's gone, you have now all the empty pairs are taken up, and you have to sit somewhere. So you sit next to somebody then, only because there's no other option to sit by yourself. And so this is what I mean with the electrons. So carbon has a total of 6 electrons. So remember, carbon looks like this. So this is the atomic number, which tells you the number of protons, and also the number of electrons, if neutral. And if we're talking about atoms, atoms are neutral. Okay, so we got to give a home to each of these 6 electrons. And so this is that first shell. And remember, the first shell can only hold 2 electrons. So the first one goes on the top, second one goes on the bottom. They want to be as far away as they can from each other. Okay, so now we have 2 electrons down, we have 4 more to add. So remember, the first shell can only hold 2 electrons, so now we need to bring in another shell. So the first one goes on top, and I like to go in counterclockwise matters. So the next one will go kind of a quarter of the way there, and then the third one, and then the fourth one. So now, if we think about it, there are seats if we're thinking about this as a clock, the 12, 3, 6, and 9 positions. So you always want to kind of fill in that direction. So we've added all 4. Remember, all of them want to be separate, so that is why we did not just go 1, 2, like that. They want to be by themselves. So let's look at another example. We have neon. So again, the first 2 will always look like that. And then we have to give home to 8 more electrons. So if we start on top, then the next one goes by itself, by itself, by itself. And this is where we were with the last element. But now, with these seats, the electron has to go, and has to now sit with the buddy. So it sits with the buddy, sits with the buddy, sits with the buddy, sits with the buddy. So you always want to find a seat by yourself first, then with the buddy. And that's it. Okay. Sulfur has 16 electrons. Let's try this one. Again, the first 2 electrons always go top and bottom. And then we have solo electron by themselves, by themselves, by themselves. Now remember, the second shell can hold 8 electrons. So we have to fill this one up first before we get another one. So then you sit with the buddy, sit with the buddy, sit with the buddy, sit with the buddy. Now we only have 10 electrons there. So then we have to add even more. So again, we're going to follow the same pattern. So by yourself, by yourself, by yourself, by yourself. And then you pair up. Now, this is where we kind of stop in terms of energy levels, because once you start getting past 18 or so electrons, it gets super complicated. Now, do you need to draw all these electrons? Yes and no. So the Bohr diagram is a great way to kind of show how these electrons jump from level to level, but there's also an easier way to show the same exact information. And so that's what electron configurations are. So this first number tells you that, hey, there are 2 electrons in the first shell. And the second number tells you, hey, there's 4 in the second shell. So the first number of electrons in shell 1, and the second number is the number of electrons in shell 2. And if there was a third number, the third shell. If there was a fourth number, the fourth shell, and so on. So, again, the first number tells you the number of electrons in the first shell, second number of electrons in the second shell. If there is a third one, it goes on and on and on. Once you get past element 20, which is calcium, things start getting super complicated. So we just kind of stop looking at it like that from then. So you're only really responsible up to that specific area for drawing these diagrams. Okay, so just like you, electrons can get excited. When an electron gets excited, it absorbs energy. Now, that electron now has more energy than it started with. And so it has to go somewhere. It can't stay where it is. And remember, electrons with more energy go farther away from the nucleus. So that excited electron jumps up to a higher energy level. So electrons absorb energy, then it jumps to a higher energy level. Now, after a while, the electron gets tired. Now, it doesn't actually get tired, it's a good way of putting it. But the electron then falls back down to its normal position, or the ground state. So when it falls back down, it has to release that energy that it had when it was on the higher energy level. So when the electron falls back down, it releases energy, and most of the time, it releases it in the form of light. So the steps in this process are super important. 1, absorb energy. This is 1. Step 2, electron jumps to a higher energy level. 3, falls down, and kind of as it falls, it releases energy. So absorb, jump, fall, release. Absorb, jump, fall, release. And again, this is how glow sticks work. So inside of a glow stick, there's actually a second tube in there. And so when you crack open the tube, you're breaking that inner tube, which has different kinds of chemicals in it. When the chemicals interact with each other, it actually excites the electrons in the dye. And when those electrons fall back down, when they jump up an energy level and they fall back down, they release that energy in the form of the light. So that's the glow stick glow that you see. Now this process is kind of ongoing. So one jumps up, one jumps down, one jumps up, one jumps down, one jumps up, one jumps down, until all the dye is kind of used up. So glow sticks, after a while, they stop working because you've used and you've excited all the possible electrons. Now, if you stick your glow stick in a freezer, you can make it last a little bit longer because temperature actually plays a part in your chemical reactions. So you can kind of slow it down if it's cold, but glow sticks will not last forever, and that is why. And depending on the dye, so orange, red, yellow, green, blue, and there are other colors, depending on the dye, it creates a different color, which I think is pretty cool. Okay, so question for you. What element is this? So let me just go back a second. I want you to notice how the electrons are being placed. So by themselves, then with the buddy. By themselves, then with the buddy. So, what element is this? I'll give you a hint. The number of electrons is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 10, 18. Okay. So you have 18 electrons. What element is that? You should say it is argon. This argon has 18 electrons, and we know it's argon because electrons equals the number of protons if we're talking about neutral atoms, and we said it's a neutral atom, so protons equals electrons, it is argon. Okay. So Another common question is, how can you tell if an electron configuration is excited or not? So your first step should be, we'll count the number of electrons to identify the element, and then open up to page 10 or the periodic table. And if the electron configuration matches exactly to the one on the periodic table, well, then it is ground state. If it's different, if it has the same number of electrons, but the numbers don't match up exactly, that is excited state. So this is what I mean. So 2-4 is an electron configuration. We have 6 electrons. And so if you look at the periodic table, the element with 6 electrons is carbon. And if you were to look at the electron configuration of carbon, you get 2-4. So that means it is in its ground state, and we know it is carbon. Now, with this example, 2-3-1, right off the bat, we can tell it's excited. And the reason is that in order to have a third shell, the second shell needs to be all the way filled up. So how many electrons can that second shell fit? So the second shell can fit 8 electrons. So you can't have a partially full shell before you grab another one. You have to completely fill up the second shell. So that's how we know it's excited. But if that didn't work for you, you could have said, okay, we have 2 plus 3 is 5, 6 electrons. We know carbon has 6 electrons. And 2-4, which is on the periodic table, does not match 2-3-1. So you know it has to be excited. And again, we know it's carbon. So try the next one. 2-8-4. What element is that? Okay. If you're thinking 2-8-4, that is 14. An element 14, or an element with 14 electrons. And again, we're looking at that because it's neutral, so the electrons equal the protons. And 14 is silicon. So now the question is it ground state or is it excited? And you should say, ground state, because it matches the periodic table exactly. Plus that second shell is full, and then it makes another one. And so that last one, 2-8-4-1, what element is that? You should say phosphorus, because 2 and 8, you have 15 electrons. So you have 15 protons, and that's what phosphorus is. And then is it excited or ground? You should have said excited, because this second shell is not full yet. There's no way you can have a shell with 4 and a shell with 1. So that would mean it would be excited. It also doesn't match the periodic table. Okay. So there are your answers again. And so that's pretty much it for today. Tomorrow, or the next video, we'll talk about atomic spectra, what that means, and kind of go into the excited electrons in more detail, and also talk about how fireworks are colorful in the way they are.